Today we're going to be talking about the graph of a function. Our goals for today are to use the vertical line test, find zeros of our functions, determine intervals of increasing and decreasing, determine relative maximum and minimum values, and determine the average rate of change of a function, as well as identify even and odd functions. So when we talk about graphs, we want to keep thinking of x as this distance across from the y-axis, and y, or f of x, as this distance up, this height from the x-axis. So let's talk about how to read a graph. We can look at the domain, the values, and the range. So our domain is all values of x for which f of x, the function, is defined. So for us, that starts here at -1, and that's included because it's a closed circle. And then it goes all the way over to 5, but that's not included, so I'm going to use a parenthesis instead of a bracket because that's an open circle. When I find the function values f(-1) and f of 2, that just means I'm finding the y point at x equals -1 and x equals 2 on my graph. So at x equals -1, we start right there, and our y value is 1. And at x equals -2, our y value is -3. Please ignore my mistake of writing 0 instead of 2 as the x value. And now we'll look at the range of our function, which is all of the y values that result from our function over its domain. So our lowest value on the y-axis is -3, and our highest value is +3. And both of those points are included. There is a point that exists there. So our range will be bracket -3 to +3. Reviewing our vertical line test, when we draw a vertical line at any point through the function, it should only intersect our graph at one point. If it intersects our graph at more than one point, then our graph is not a function. And now we'll talk about the zeros of a function. The zeros of a function are also known as the roots or the x-intercepts, and those are x values where f of x, where our y equals 0. So we already know how to do that graphically. We just find the points where our graph intersects the x-axis. So here that's at 1 and 4. So let's take a look at how to do that algebraically. We know that these zeros are where f of x equals 0, so I'm just going to substitute 0 wherever I see f of x. So I'm going to set that whole function equal to 0. I'm going to factor because it's a polynomial, and then I'm just going to solve for my x values. I get x equals 5/3 and x equals -2, and my full points coordinates for those x-intercepts are 5/3, 0, and -2, 0. And we're going to do the same thing over here. We're going to make g of x equals 0, so I have 0 equals square root 10 minus x squared, and I'm going to keep solving till I get x by itself. This one looks a little funky, but I'm going to do the same thing. I'm going to set h of t equal to 0, so 0 equals the rest of my equation, and I'm going to multiply both sides by t plus 5 to free up that denominator. And what's going to happen is I get t plus 5 times 0 is just 0. So this time I'll only get one x-intercept at t equals 3/2. Let's talk about how to identify decreasing, constant, and increasing intervals on a graph of a function. So our definition of increasing is as x goes to the right or increases, our f of x, our y's, are also increasing and going up. So we can see that over here. As x gets bigger, so does y. So we can see that that interval starts at 2 and ends at 4. I'm going to use an open interval with the parentheses instead of the brackets to describe this interval because at point 2 and at point 4, the function's not increasing nor is it decreasing. It's changing at those points, so I can't include that in my interval of increasing. And on the other hand, decreasing means that as x gets bigger, our y's, our f of x's, actually go down. So we can see that on the interval -2 to 0 on this graph. Now constant means that as x gets bigger, f of x, our y, does not change. So we can see from 0 to 2, our y value stays the same all the way across. Let's do some quick practice. So on this cubic function, x to the third, I can see that as my x gets bigger, my y is always getting bigger. So this is increasing over its whole domain from negative infinity to positive infinity. Now we're looking at the middle graph, x cubed minus 3x. I can see that there's turning points at -1 and x equals 1. I can tell that from negative infinity to 1, my function is increasing. And I can tell that the same thing is happening from +1 to positive infinity. Now looking from -1 to 1, I can tell that my function is decreasing. As my x goes to the right, my y values go down. So on this last example, this piecewise function, it's 3 different linear functions put together. So I can tell just by the slope of my functions. So from negative infinity to 0, my slope of that line is positive, so I know my function is increasing there. So now at the end, from 2 to positive infinity, my slope is -1, so that means my function is decreasing there. Now in the middle, that's a straight line. My slope is 0, so my function is constant there. Let's talk about minimums and maximums, the points at which a function changes its increasing, decreasing, or constant behavior are helpful in determining our mins and max values of the function. So let's first identify those values where our function is decreasing and increasing. So now we're going to find the points where it's changing from decreasing to increasing and increasing to decreasing. When it's changing from decreasing to increasing, that means we have a minimum. And then when it's changing from increasing to decreasing, that means we have a maximum.